So we're going to problem solving with derivatives of sinusoidal functions. So there's a very large problem we read, and we kind of just picked out the important piece of information. They've been given a question about a pendulum. So a pendulum, kind of think of like an arm of a clock swinging back and forth, right? And the period of the pendulum is represented by t, which is, or capital T in this case. And the equation of that is 2 pi times the root of L over G. L is the length of the arm of the pendulum. Whoops. And in our case, they've actually given us that information. It's 1 meter. Okay, divided by gravity, we're going to assume we're on Earth, so gravity is 9.8 meters per second, so we're going to replace G with our 9.8. Okay, they've also told us given us another question or equation that gives us the height of the pendulum in reference to the time when it starts swinging, and that is equal to A, which represents the amplitude. Okay, and they've given us again the amplitude of this is 5, so the distance from the middle, I gotta stop making a circle at the bottom. The distance from the middle to one side to the other is going to be 5. Okay, so this is 5, and that would be 5 too. Cos 2 pi t reference the time, and t being our period. And they want us to find, and I should have written this out. What do they want us to find? The max speed. Okay, they want us to find the max speed, or in other words, kind of the maximum minimum of our sinusoidal function. Okay, so to find our maximum, we're going to derive the function because we know that if we set it equal to 0 when we derive it, we'll be able to find a tangent that is horizontal. So we need to get info. For instance, we need this a, and we need this t value. So in order to do that, we can plug in 5 for a. That's really straightforward. But we actually have to solve for the period of our t. So we're going to go about doing that first. So t is equal to, I'll kind of do it on the side, 2 pi root of the length was number 1 over 9.8, and we'll figure this out from here. So 2 pi times bracket the root of 1 divided by 9.8 end bracket, and then I think end bracket again, and it's roughly 2. So let's just go with the number 2 here because it looks like it's got quite a decimal. So that worked out very nicely. Our t is going to be the value of 2, and we already know a is our 5. So we can finally build our equation that we're going to derive. Height in reference to time is equal to 5 cos 2 pi t over, and I guess maybe I should highlight these. That this is the number 2, so we're replacing the uppercase t with 2, and we got 5 from the amplitude. So that's where we got our number 5 from. Okay, and we can do a bit of simplifying before we derive. Our 2's are going to cancel out, so we're left with 5 cos pi t. Okay, so we want to derive this function. So we're looking for h prime t. Okay, and you can kind of think of this like a product rule. First off, 5 times cos, technically it's, sorry, did I say product? I meant chain rule. This is kind of like a product rule. 5, derivative of 5 is 0, so 0 times cos pi t eliminates. And then we do 5 times, oh, and I need a pen that stays, 5 times derivative of cos. Well, the derivative of cos is actually negative sine, okay, so times negative sine. And then we have, I'll kind of write in brackets, our pi and t. But because the derivative of this part is kind of like a chain rule, we also have to derive what's inside this bracket. And when we derive what's inside this bracket, it's like t being to the power of 1. We multiply it by the pi in front, and the t kind of disappears. And we're left with a pi on the outside. Did that step make sense? Okay, so we're left with a pi on the outside. So when we go to simplify all this, or multiply everything together, think of it like having negative 5 times pi sine pi t. Okay, so we've now derived our function. This is our derivative, negative 5 pi times sine pi t. We want to set it equal to 0. That's the whole goal. Okay, so our first derivative helps us find essentially the velocity in terms of time, and not velocity, derivative velocity. It's a velocity in terms of time. But I should have been more specific. I guess they want to find max speed. So we're looking for acceleration, which means we have to find the second derivative of our height in reference to time, or the derivative of our velocity. Okay, so the derivative of our new found velocity of the pendulum, so v at t, or the acceleration of t, is equal to, we're going to derive this function again. So let's set this up. Our product, same idea, negative 5 pi ends up being 0, eliminates everything. So we have negative 5 pi times, again, our sine. The derivative of sine is cos, okay? And we'll kind of put it like this. Inside the brackets, pi t. And again, we have to derive inside those brackets, kind of like a chain rule, same as before. It ends up being, derivative inside the brackets is pi. So when we go to simplify this again, we have negative 5 pi squared, okay, so we multiply those, times cos at pi at t, okay, and we're looking for when acceleration is 0. So we're going to set this equal to 0. 0 is equal to negative 5 pi squared cos pi t. In order to do this, we divide both sides by negative 5 pi squared. Okay. These conveniently cross out. This ends up at 0. 0 is equal to cos at pi t. Okay. Now the whole goal is to isolate for t itself. So one of the things I can do is I can bring cos to the other side, or find the inverse of it. So we can do cos inverse of 0 is equal to pi at t. Cos inverse of 0, do you know what that gives us? A chance? Look it up here. Cos inverse of 0 gives us actually a value of 1. We're looking for our angle here. Think of it like sine at 90, I guess. So we get our value of 1. So our value of 1 is equal to pi times t. Okay. Okay. So we're finding cos inverse of 0, which if we use a sinusoidal function, okay, that 0 is 1, and we're looking for when our y value is 0, and one of them being pi over 2. And it turns back up at pi, and 3 pi. Is this right? Yes, 3 pi over 2, and then comes back up at 2 pi. Okay, good. So our idea of pi over 2 as one of our kind of options here, okay? So we have pi over 2 is equal to pi at t. And again, technically there are numerous answers to this. We're going to stick with our pi over 2 and then build our equation from there, because we're going to have many, many answers as we go through this. To isolate for t, we're going to divide the other side by essentially pi. So when we divide by pi, our pi's cancel out, and you're left with a half, or 0.5 is equal to our value of t in this question. So we have found either a max or a minimum in speed, right? This is our acceleration being 0. So we're either increasing acceleration to a point and probably decreasing after, or negative after that point, right? So let's think of this like it's a pendulum, okay? So a pendulum swings to the right and to the left, okay? And these are points when it changes directions, okay? So because it's changing directions, essentially our speed is 0 at these points, okay? And then what is happening is it starts to come back down, hits this point here, and then swings back up, okay? We can, by looking and knowing how a pendulum works, go on the assumption that this is where it reaches its maximum speed. Essentially is heading back down towards Earth, and then is going back up and starts to fight gravity. So because it is fighting gravity here, we can assume that the acceleration is decreasing, assuming that we're swinging this way, and increasing when we're coming down. And then on the way back, it's increasing on the way down, and then decreasing on the way up with gravity, okay? So one of the ways we can prove this is a max is if we can show that this height in reference to the middle of the pendulum, okay, the distance away it is from its center is 0. And one way you can do that is by plugging into the original equation as a test. So the original equation being our h at t, what do we find it to be? is equal to 5 cos pi t. Okay? Now we said that t was a half, so we're going to replace t with 1/2, which means we're going to get 5 cos pi times a half, okay, which will give us 5 cos pi over 2. Now, if we know our sinusoidal functions, pi over 2 is essentially 0. So when we multiply this, we're talking about 0. So at this point in time, our height from where we originally, or what we consider the middle, is 0. So we know that this point in time, at 0.5 seconds, we're directly in the middle. And from our assumption of gravity having a pull on us, we know this is a maximum speed. So this is max. So we can take this now and figure out by plugging into our velocity, which our velocity equation was back up here at 0.5 seconds, we can figure out what our max speed is. Maximum speed of the bob. So we now take our velocity question, our velocity, so v at 0.5, and we'll take our equation, -5 pi sine pi t, so -5 pi sine pi at, and then we replace t with 0.5. Okay, this is going to give us -5 pi. This is going to be sine pi over 2. Sine pi over 2 is going to give us a value of 1. Yeah, so -5 pi times 1, which will give us -5 pi. And if we were to multiply that actual value, -5 times pi, -15.7 roughly. So -15.7 is where we're reaching our max speed. It's probably in meters per centimeter. Is that what we're in here? I think we're in centimeters, I guess, in this question.